This video is presented to you by www.testprepadda.com. Dear students, whenever you read or listen word motion, you should be careful. Motion can be one-dimensional, it can be two-dimensional, it can be three-dimensional. Motion of a particle along a straight line. This is described by only one component, that can be velocity or acceleration. Means you can describe this motion by either Vx or Vy or Vz. Similarly, you can describe this motion with Ax or Ay or Az. So this motion that is along a straight line can be horizontal, can be vertical, can be slanted. Okay. Now, if I throw a particle in vertical plane at some angle with horizontal, and that is not 90 degree, like this. This is the horizontal plane. Now I will throw in vertical plane at an angle, let us say theta. Then what will happen? We get motion of this type. This is two-dimensional motion. This is two-dimensional motion. So this motion, this is called projectile motion, is an example of 2D motion. Here velocity and acceleration are described by two components that are mutually perpendicular. Like you need Vx and Vy to describe the motion, or you need Ax and Ay to describe this motion. Got the idea? Now, you must have seen motion of a monkey. It is a three-dimensional motion. Here, velocity and acceleration are described by three components, mutually perpendicular axes. So, for 3D, we need Vx, Vy, and Vz, or Ax, Ay, and Az. Got the idea? Now, the conclusion is for one-dimensional motion, we require one variable, or this is described by one variable, x or y or z. And two-dimensional motion is described by two variables, x and y, or y and z, or Z and X. Now for three-dimensional motion, we require, or this is described by three variables: X, Y and Z. Got the idea? Now I am going to talk about one-dimensional motion under uniform acceleration. Consider the motion of the particle in x direction. If I take this as the origin, this will be the positive x direction and this will be the negative x direction. Let the velocity of the particle at time t is equal to 0 is u, and at time t is equal to t, let the velocity is v, and let the particle at time t is equal to t is at position x. Okay, and the particle is moving under a constant acceleration a. The acceleration is constant. Okay, now we have already learnt the acceleration as dv by dt. Okay, so I can write this as dv is equal to a dt. Now if I integrate at time t is equal to 0, we have said that velocity is u, and at time t the velocity is this v, and if you integrate this, we get v minus u is equal to, since a is constant, we'll take this out of this integral, it become a, and integral dt is t and limit is 0 to t, so finally it comes as at. So we get relation between initial and final velocities in this manner. U is the velocity at time t is equal to 0, and this v is the velocity at time t, and a is the acceleration during the motion. Now we have already learnt about the velocity. Velocity we can express as dx by dt. Okay, so we can write this dx by dt as u plus at, because we have already defined v here in terms of u and t. And now if I write this as dx is equal to u plus at dt and integrate. We have already said that at time t is equal to 0, the particle is at position 0. And at time t, the particle is at position x. And when you integrate, integral dx is x, limit is 0 to x, so it becomes x minus 0, and that is x. This side, it will be ut plus, this is t dt, so t square by 2, and effectively when you apply limit, it becomes half at square. Got the idea? Now to get the relation between v and x, I'll square this equation 1. Consider this as equation 1 and this as equation 2. So when you square, you get v square is equal to u plus at whole square. So I can write this as u square plus a square t square plus 2 UAT. Now, take 2a common here. If I take 2a common here, then this will give you UT plus, and here you will get as half AT square. Okay, so UT plus half AT square is what? X, and that is why it becomes 2ax. So finally, the relation comes as v square is equal to u square plus 2ax. This is the third equation. So, three equations of motion. Motion along a straight line under a constant acceleration. Got the idea? And the important point here is this x is actually the position. This x is the position of the particle at time t. It is not the distance traveled from 0 to t. It is the position of the particle. So what are the three equations that we have obtained here? V is equal to u plus at, x is equal to ut plus half at square, and then v square is equal to u square plus 2ax. Now the important point. Please note here this x is not the distance traveled by the particle from 0 to t. You may get confused here. Consider this as the origin, and at time t, the position of the particle we have said as x. Please note, this is the position of the particle. For example, if the particle is at origin at t is equal to 0 and goes to, let us say, 10 meters, and then comes back, and at a time t, if I say the particle is at 6 meters, then the distance traveled will be how much? This 10, this 4, so total distance covered will be 14 meter. But the position x will be taken how much? Will be taken as 6 meter. Okay, you can say that this is the displacement. You can say this as the displacement from the origin. So we can also write this as S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. This S is actually here x minus 0, position of the particle at time t, and the position of the particle at time t is equal to 0. So this way we get the displacement. Got the idea? Dear students, although we have derived these equations of motions using one-dimensional motion, but in the next video lecture, I will tell you how to use these equations when the motion is in a plane or even three-dimensional motion. Okay? This video is presented to you by www.testprepadda.com. Testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.